Hey there folks, welcome back to the Speaker Builder channel, and today we're doing another topic video, and today's topic is all about crossovers, and the topic title being passive crossovers versus active crossovers. So we're going to talk all about that as a part of our design series. And so we first of all want to understand what a crossover is. Well, we're going to talk actually about functionally about what a crossover does. And very, very simply, a crossover is a solution to a bunch of problems. So the problems that I refer to are those that are introduced when we go from a single driver to a multiple driver system. If we were in a perfect world and we could have these full range little speakers like these, and they would be all things to all people and they would sound great, we wouldn't have to worry about crossovers. But this driver won't do the highs really exceptionally well. It won't do the bass hardly at all. And so in order to get into real high quality sound, we've got to get into specialized drivers like the high quality tweeters like these Focals or these new Etons are wonderful. And then utilize either low mid frequency driver like this two-way system or a mid-range, a smaller mid-range driver like this for a three-way system. So because we have drivers of disparate qualities, we're going to run into various kinds of problems. And so let's talk about what those problems are, and then we'll understand what a crossover is going to do for us. So one of the problems is that we have these two drivers, and they may not have the same level of sensitivity to the signal coming in to your speaker box. So if we were to just hook this up to a driver and run another set of leads over to the tweeter and have them in parallel, it might be that the tweeter is a little louder than the mid-range driver, meaning that your response is not going to be flat. It's going to be at such nominal level, and then at the high frequency it's going to be brighter. That would not be good. Or conversely, the mid-range driver might be a little brighter than the tweeter, and so you would have, it would drop down for the high frequencies. So that's a problem. You can't possibly expect to select drivers that are going to be all things. You're going to have drivers of different levels of sensitivity, and so you're going to have a problem in the balance. And so the crossover is going to deal with that. So that's one problem. The next problem also has to do with the level of amplitude across the frequency spectrum, and the problem is apparent when you think about the point at which that the driver is going to cross over. That's what this crossover word is all about. The frequencies are crossing over from one driver to the next in a multi-driver system. And so as you think about that, in a perfect world, the mid-range driver would produce frequencies up to a certain point, and then it would be hard-walled down. And I think some folks are looking at making digital systems. You convert the signal to digital, and then you do it you make a hard-wall crossover. But in the analog world here, down here at the speakers, you're going to have frequencies on a rise up to a certain frequency, and then the response is going to slowly drop off. And then with the tweeter, the other way around, you'll have frequencies going down that will get to a certain frequency point, and then it will slowly drop off. And what you end up with then is a band of frequencies somewhere between the mid and the tweeter, say 500 cycles up to 4,000 or 5,000 cycles. This what's called a band pass, in which both drivers are operating. And there are two problems with that. One of them has to do with amplitude. Obviously, if the nominal level of response is at a certain point prior to the crossover region, when both drivers are operating, you're going to have this climb. You're going to have a greater level of volume, and then it's going to drop off. So there's going to be this little bump in that crossover region, and that's a problem. And so the crossover is going to deal with that bump. And then the third problem is that you've got, with that band pass with both drivers operating, you've got both elements producing the same waves, the same frequency, and those waves are going to interfere with one another and cause various kind of problems, phase problems and cancellation and various kinds of peaks and nulls, and there's just a host of different kind of problems. You've got polling going on. There's all kind of problems that are introduced when you have two drivers producing the same frequencies, and especially if they're disparate, they're different kinds of drivers. So that crossover range, that band pass, is a problem for operating two drivers. And so the crossover is going to deal with that. So, and in the way the crossover is going to deal with it, it's going to attenuate this tweeter below a certain frequency. So the tweeter range going down to about, say for this one, say about 3,000 cycles, the crossover would then attenuate that so that the drop-off is very sharp, and then above a certain frequency, above 3,000 say, the crossover would attenuate the response of the mid-range driver at a sharper slope. So now your bandpass is much narrower than it was. So the crossover's got to do all three of those things. It has to deal with the differences in amplitude of the different drivers. It's got to deal with this potential peak in amplitude in the crossover region. It's got to fix that by adjusting the point at which each driver is attenuated. And then there's a need to sharpen the attenuation slopes of each driver to filter those more dramatically on either side of that crossover, so we have a much narrower bandpass. So we don't have so much of a problem. We can't eliminate the problem of a bandpass, but we narrow it. In the case of my electronic crossover, I have a 48 dB per octave bandpass filter, you know, at the tweeter and between the tweeter and the mid-range driver, and so it's an extremely sharp slope. So it's almost a hard wall. Almost a perfect transition from the mid to the tweeter. So anyway, that's the idea. So a passive crossover has to fix those, well, a crossover has to fix those problems. And so now we're going to now talk about passive versus active. So what is a passive crossover, and how does it differ from an active crossover? So now we know what a crossover has to do. Now let's kind of look at what a passive crossover then. First, because it's passive because there's no electricity being supplied to it. It doesn't have an electrical circuit that needs power to drive it. It's going to operate passively without any power. It's a non-powered. And in the musical instrument world, we have passive pickups and active pickups that need power, need a battery power or something. In this case, we're going to have the signal coming into the speaker box from your amplifier, and it's going to then go through a series of components. And these are actually crossover components, so they're cheapy ones, right? But a coil, air coils, capacitors of various kinds. They're usually bigger than these. I've seen little cheapy capacitors like this in crossovers, and then resistors. And all of that in a complex circuit results in these fixing these problems so that these drivers can work together. So the passive means that it's out here at the speakers, and active means that it's going to happen, and I'll talk a little bit more about active in just a minute, but we're talking about the passive side. The active is going to be prior to the amplifier. So let me finish and say some things about passive crossovers. There are a couple of things I want to say since we're talking about crossovers here. And one of them is that ordinarily in speaker systems, if you try to produce a passive crossover with the various parts and you create that circuit, you can successfully do that for a two-driver system without too much difficulty. And so once you get into a three-speaker system, I'm going to use my 8-inch driver as an emulate. I normally would do tweeter mid-range, and then I might have a 10 or a 12. I don't have my 12-inch driver or 10-inch driver out of the box, but anyway. So you have a bass driver, you have a mid-range driver, and your tweeter. So in this case, there's the what it would call for an entirely a passive world would be a three-way passive crossover system instead of a two-way passive crossover. And the literature tells me from way back, tells me that three-way crossovers introduce various other kinds of problems electrically into the system that makes producing a three-way crossover problematic on a number of fronts. So the recommendation to that I'd recommend, if you want to build a passive crossover system, do so with your what's called the satellite speakers, the 6.5 two-way or the 5 1/4 two-way, whatever. Use a two-way passive crossover at this end, and then for the bass driver, use an amplifier and have either an active electronic crossover or have just a filter on the amplifier or something like that. So deal with this crossover point between the mid and the bass driver at the electronic end. At the amplifier end, you could have filtering so that the amplifier doesn't produce anything above 100 cycles, for example. so that it only produces 90 cycles. At this side, you can actually build a passive, build a speaker system in which this driver, because it's in a small sealed box, won't produce anything below 100 cycles anyway. So that's kind of the some of the concerns. If you're going to go beyond two-way passive crossover, you run into potential problems. And so with a three-way speaker system, there's a workaround there. Just use an amplifier and do an active system, which is what a lot of powered speakers are. They have a pair of passive satellite speakers and then an active amp driving the single, or I always have two bass drivers. So that's an issue there, and a workaround there. In the case of this 8-inch two-way system, I've kind of cheated a bit, because I'm using the 8-inch driver for bass and mid, and then I'm introducing a tweeter. And so there we don't need a crossover point between the bass and the mid, because a single driver is doing all that. It's not getting the kind of bass that a 10 or a 12 can give me, but it's getting really good bass nonetheless. And then I cross over a single crossover point, so I could use a passive crossover here. And my 8-inch two-way passive speakers are of that design. This is a 6.5 two-way, same kind of a thing, a full range speaker system with a 6.5 and a tweeter, and it only has the one crossover point to deal with. So it's a two-way crossover in that system. So I pulled this out so you can see I'll put this camera inside there, and we'll take a look at that cross. You can see the crossover inside there. So that's some kind of issues. There was one other issue about passive crossovers that I didn't mention, because I forgot, because I knew there was a fourth issue, and that is when you have, if you were to again potentially hook up both of these drivers directly and not use any crossover parts, you would be putting full frequency range to this driver, and you really ought to filter that out, because you can burn this driver out trying to drive it with 100 cycles, 500 cycles like that. So by filtering these so that it never sees anything, say, below 2,000 cycles or 3,000 cycles, this driver can push a lot more power without burning it out. So you can get the more power out of it. As you try to hard drive this with full frequency range, you'll kill it more easily. So that's a third problem in a multi-driver system. A fourth problem, I mean to say, that I didn't mention before, that I just thought of. Okay, so we talked about passive crossovers, and I mentioned that the three-way passive is problematic and a two-way is better. Now there's another thing I want to mention about crossovers. There's a lot here to understand and to know about. And the other thing I want to mention, that oftentimes folks will buy a couple of, or they'll have a couple of drivers, and they've actually asked this question on here on Speaker Builder: will this generic crossover work for my drivers? So let me mention that there are these generic crossovers, passive crossovers with coils and capacitors and resistors, and they're generic. They're designed just for any set of drivers. But you have to keep in mind that the parameters involved here are extremely specific. And so if you really want to get nice flat frequency response and get these two drivers to work together properly, you have to build a proper crossover specific to these two drivers. So a generic crossover isn't going to get you there. You're going to have bumps and problems in your frequency response using a generic crossover. So the idea of folks building generic crossovers and folks buying those and putting those into systems is, in my mind, a bit ludicrous. Now, if you don't have any money, you're really on a super tight budget, okay, I can understand that, but don't expect nice, even, smooth, flat response. You're just not going to get there. So make sure that's a real budget project. Don't spend big money on it, and then put a generic crossover, passive crossover in the system. That would be foolhardy. If you're going to do crossover, passive crossover, and you want high quality, then you're going to do it right. And to do it right, you have to build the crossover specifically for the drivers you have selected. So that involves two things. Either you're an expert, as I'm not, on crossover design, and you spend the time and you put some you do all the math, and then you put some hypothetical parts in there, so your best guess values of capacitors in a circuit, and then you listen and you test, and then you change values of parts and move them around, listen to it some more, test some more, then move and you can spend weeks doing that. And that's what folks do. They build passive crossovers by ear, and they're experts at that, and that's way beyond what I can do. And I would not encourage most folks watching Speaker Builder here to tackle that. There are some who can do that, that's wonderful, but I think that's just, how many, unless you're going to build 100 of those, I think that's just nuts for me to try to learn how to do that myself. So I'm not going to do that. What was the workaround? One of the workarounds was that I back in the day I had Focal was making systems with designed crossovers that they designed, and you buy the whole, you get the plans for free, and it designated specific drivers that were available at the time, and it gave you the whole crossover circuit. The entire crossover. So here, build this crossover with this circuit, and you just went to Metasound, you buy the parts, and you put it together. So that was a nice workaround, and I had that system for many years. The next better way to go is that and this requires that the drivers be measured independently, and then you can use software like the LEAP software, L-E-A-P, LEAP Loudspeaker Enclosure Analysis Program, I think is what it stands for. And what it does is it takes, if you measure, and Metasound is using LEAP, and they measure the drivers independently in their anechoic chamber. Now they have those parameters, actual real world parameters, that they then put into the software program. And then you tell them, I want to buy these two drivers and I need a passive crossover for these two drivers. They'll put those two drivers in, and then I was reading the website, they actually go through and theoretically build it in a computer simulation. They build this crossover. It'll start off with a certain set of values, and the computer will spit out a hypothetical response curve, and then you adjust the values, and then you see, and then there'll be one of the guys working there who will sit there and play with it and adjust all the values until you get hypothetical flat response. They get these two drivers to work together, and then that's your kit. So that's your design. So the designs are very specific, and so this idea of genetic crossovers, once you know the complexity of that, of getting a crossover to work, the idea of genetic crossovers is just foolhardy. No factory system is ever doing that. The factory systems all have crossovers specifically designed for the drivers they're using. That's the problem here. I replace this driver, that the crossover is not designed for this driver. So, it is what it is. This is just a cheap system that I keep downstairs in the shop. I don't care. This is not for high fidelity. Otherwise, I would get a separate driver, a tweeter, and I would take that mid-range and Metasound. I got it from Metasound, and they could build me a crossover, design me a crossover for it. But I'd have to start with fresh drivers from Metasound that they have had or that they currently sell, and then they can design a crossover for you. So that's kind of I don't know anybody else doing that. If you have any ideas about who else is building crossovers for specific drivers, Metasound's the only one doing that. That's the correct way to do it for passive crossovers. So let's talk about active crossovers just a little bit. I don't want to spend a great deal of time on the active because I don't know how many people are going to be doing that. And I've covered active crossovers in a bunch. But I want to introduce the idea of active crossovers a little bit. So in an active system, we're doing the very same thing. We're getting these two drivers to work together. But we're putting that crossover in before the amplifier, before the signal comes in to the speaker cable. Now, why are we going to do that? What advantage is there? Well, if we put these parts, these coils and capacitors in line with the signal, as the signal comes in to the speaker box, and then it goes through a bunch of crossover parts, and we'll take a look at this one here, and we see the complexity of that circuit, and it has to go through all those parts, and then it comes out and goes to the drivers. You can expect the signal is going to get constrained and be limited, and then the response from the driver is going to be limited, and so it's just, you're going to hear that difference. There's a pretty dramatic difference, especially in high frequency response, between a system that has a passive crossover on the one hand and that same driver in an active system. Big difference. So passive crossovers can work okay. I don't want to discourage it. If you are going to do a passive crossover, I recommend using the metal dome tweeters that tend to be very bright. Go ahead and don't be afraid. You can't get probably a tweeter that would be too bright in a passive system, because the passive crossover is going to dampen the brilliance of the tweeter quite a bit, and so you can't get a tweeter that would be too bright in a passive system. But in an active system, I'm struggling with that. Whether these are too bright, whether I'll try these out in just a little bit. These Etons, some of the tweeters that I've had. They tend to be just too bright in an active system. And the reason why is because we have eliminated all these passive crossover parts. So now in an active system, you have the leads coming in, one set of leads coming in driving the mid or the bass mid, and another set of leads coming in and driving the tweeter. And it means you have to have separate amplifier channels. And so an active system would then require, for stereo, one stereo amplifier driving the mid-range drivers, and another stereo amplifier dedicated to the high-frequency drivers. And then in my three-way system, I have another stereo amplifier that drives two, in this case, 12-inch bass drivers. So it's three-way electronic active speaker system. So it requires multiple channels of amplification. And then we have to have an electronic crossover, and that is going to be powered. It's going to utilize power from some source, usually low voltage DC, but you have to convert that from AC, right? So you've got a power supply in there in the active crossover, and then you have low voltage electronic crossover circuit. And the nice thing about the electronic circuit then is because the signal's coming in at a low voltage and high impedance, going through all those electronic components doesn't degrade the quality of the sound near the extent happening out there before the amplifiers, as is the case when the signal comes through after the amplifiers and you're going through these components passively. That's going to have definitely a dampening effect on the quality of the sound. So obviously the advantage, and I should mention that and talk about that a bit, so there's great advantage obviously in using a passive crossover, and it's simply about simplicity. You just need one stereo amplifier per channel, and you need one box, and so you have a box like this with a passive crossover. It's a complete unit. You just hook up your speaker wires to the back of that and you're ready to go. And especially if you're doing 5.1, you know, to do multi-channel 5.1 surround for active system is really complicated, versus if passive satellites, in the case of satellites with just one crossover point, you could have 5 of these in the room with passive crossovers. And then you have a separate amplifier that drives your bass, single bass or double or two bass or whatever. That's advantageous. You only have one set of speaker wires going to each one of your satellite speakers. So there's places and situations in which passive crossovers are perfectly appropriate. And most speaker systems out there are utilizing passive crossovers. I've gone kind of crazy on electronic crossovers, another word is active speaker systems instead of passive. Because of the additional clarity of the system. And so it's more expensive, it's more complex, you have more amplifiers to deal with. You have the electronic crossover out there prior to the amps, which might cost about the same money, by the way, but then you have multiple channels of amplification you need, and then you have multiple speaker cables that are utilized. You know, instead of 2 sets of speaker cables, you get 6 for a 3-way in my case. Now, one of the things I did with and I've got to finish this project up, but one of the things I did to do active system and to keep it simple was to do a full range 2-way system, 8-inch 2-way system, and do that active, because I still only have one crossover point. And this is a nice, by the way, is a passive system. It's a wonderful way to go. Simple, two bass mid drivers, 2 tweeters. So I would encourage this in a passive model. But I've done this active, and it means only one crossover point in the active realm, and then 2 stereo amplifiers instead of 3, or it's like that. So it simplifies, you know, the active system. It produces an active system and keeps it simpler. So I thought it was a really nice way to go, and so I built that active 2-way system some now 3 or more years ago. And so I'm in the process of rebuilding that. I got a video coming on that. But if you want to look at that, and by the way, look at more about what an active speaker system is, I share some of this information about passive versus active in that video series. It was one of the early videos that I did, and because it was an active system, I wanted to spend the time and explain all that. So I go into great detail in that project video called Active Speakers. Is like 5 parts. And I go into great detail all about active versus passive there as well. But this video is really sort of an introduction to some of the issues involved. So I hope that covers everything. Passive versus active. Passive speakers mean a passive crossover here, getting these 2 drivers to work. That involves various parts. You really need to go to Matasound or I don't know where else you can go And you can get a book on how to design them and stuff, but I think that's even beyond what I want to try to tackle. I would go to Metasound, I would use their Leap software, I would buy the drivers from them to do it right, to do passive correctly, to do it well. Otherwise, I would avoid the unless you're really on a super cheap budget, I would avoid the generic crossovers passively. And then the electronic, the other advantage of an electronic or active speaker system with an active electronic stuff, you can put any driver in here you want. You're going to balance, you know, you don't have the issue of getting of trying to having a specific circuit like I did here. There's a specific circuit for the bass driver that was originally in this box and for this tweeter, and then the bass driver failed. I replaced the bass driver, but this crossover won't work in this system. Whereas if I have this in an active system and this driver fails and I can't find this anymore, I can go get the Eton and put the Eton in here and just make it work, and I don't have a passive crossover that I would have to throw out and start over again with. And so, because the crossing over is happening at the electronic end, and then the amplifier is coming in and operating this directly. So the only issue is amplitude now, not getting the speakers to work together. So you've removed some of the complexity of crossing over the drivers by going active. So it's a more complex way. The active is a more complex way to go, more costly, more amplifiers, but higher quality. Definitely higher quality. So, and some of the and it's finally one other comment. I may be jumping around a bit, but one other comment on electronic crossover is in the active speakers. I share that electronic crossover that I built. You see that in that video, and some of the other options that you have for electronic crossover. If you don't want to try to build one like I did from Phil Marchin's stuff. There's two other options. I'm not ready to try to introduce one of those two. It has to do with this X-Kits. They have these little amplifier modules that have the electronic crossover right in as part of the amplifier module. It's a 2-channel amplifier module with electronic crossover right in the box. It's called X-Kits, xkitz.com, and you can look at those. That's kind of an alternative way to do that. I just discovered that in the past year, and I want to utilize those in a future project, actually, this project here with these two drivers. I'm going to use the X-Kits. So that's a video coming next summer to a theater near you. But so you can take a look at the active speakers. You have that electronic crossover you can look at, and then for some of the other projects I've been doing mostly electronic crossovers. In most of the projects, the satellite subwoofer speaker system, that's an electronic system. My truck speakers and Truck Speaker 2, those are all active systems. And they're utilizing the the auto electronic crossover from Audio Control. So you can take a look at those. If you want to explore more about electronic crossover, you can look at those projects. But that's about as far as I want to go. I don't want to actually get out this electronic crossover that's below the desk here, but that'll be as far as we go today. So I hope that's clear. Please comment, and we will see you all next time.